So let's have a look at some simple examples. All we're doing is just doing exactly the sort of thing that we did earlier on in that first example. So I've got 3x equals 2x plus 5. Now, like I said before, I want to get my x's by themselves, and at the moment this x is by itself, so I'm not going to move these x's over here. And there's another good reason for that that I might explain later. It makes much more sense to take this x and move it over there. So remember, this is plus 2x, so the opposite is minus 2x. So I'm going to subtract 2x from both sides. At every step we cancel something, so that's cancelled now. On this side, 3x minus 2x, I'm left with 1x, or I'm just going to write x. On this side, my 2x's have cancelled, and I'm left with 5. So in a lot of ways, this particular one ended up being a one-step example. Anything like that where you've only got one number and two lots of x's will probably work out in one step. So same deal, x's are by themselves, so I obviously want to get rid of this minus x. Now we are subtracting x, so the opposite is to add x. To both sides, these will cancel. All I'm left with is, so minus 24 on the left hand side of my equation, 5x plus x is 6x. No, actually I tell a lie, this will be a more complicated one, because the reason this was simple up here is, of course, we ended up just with 1x, but now we've got 6x equals minus 24. The last step is to divide by 6, because we were effectively multiplying by 6, so the opposite of that is to divide. These cancel, this division we can work out, and so I'm left with x equals minus 4. Now remember, be careful with your directed numbers as well, and the rules for that were in the previous video and the previous notes. Slightly trickier examples where we've got pronumerals and numbers on both sides of the equation, but we just follow the same rules. Now in this case, in the case of the first one, I'll think about what to do with my x's first. Now, you might remember I mentioned that I'm going to keep my most positive x where it is. So 2x is more positive than minus 3x. If I was to move the 2x, then I'd end up with a more negative number of x's, and then I have to deal with that later, which is just messy. So to get all my x's on the left hand side of the equation, I'm going to add 3x to both sides. Now these will cancel. 2x plus 3x is 5x, plus 3 equals 33. Then it becomes a very simple question after this. It's just like the ones from the previous lesson. I will subtract 3 from both sides. These will cancel. I will end up with 5x equaling 30. I'll divide both sides by 5. And I'm going to end up with, because these will cancel, x equals 6. Now, this next one is a little bit trickier. Now, I've thrown this in here just to combine a few of the ideas that we've talked about and to show you that we can deal with things in lots of different ways. Now, if you remember, we're going to do our order of operations in reverse when we're solving. Now, I would like to get my x's together, but this is a horrible mess that I need to sort out first. So I need to sort out all these denominators and stuff. Now, what I'm going to do though, because subtraction and addition are the first operations I would look at when I'm solving, I will get rid of this 3 anyway. So I'm going to go minus 3 to both sides. They cancel, and then what I'm left with is 2x plus 5 over 3 equals minus x plus 15. Now, this is a lot like some of the examples we talked about in the previous video, where although you can think of this as being 2x over 3 plus 5 over 3, if we're going to work on it like that, then we do a lot of calculations with fractions, which are generally more confusing, and let's be honest, everyone hates fractions. So what we're going to do instead is we're going to treat this as being a single binomial factor with a denominator there, and so we're just going to, now that I've put the brackets around it, I would do the division operation first. So the opposite of dividing by 3 is multiplying by 3, but when you do that, you have to make sure that you do it to everything. So not just this side of the equation, not just minus x, but actually everything. So what I'll do is I'm going to throw a bracket around that. Now, I'm running out of room here, so let's zoom up this side. So what happens? Well, 3 divided by 3 cancels. So my left side is actually becoming quite simple. So I've got 2x plus 5 equals 3 times minus x plus 15. Now, to be honest, I'm actually jumping ahead here because the next section of the chapter is actually ones that have brackets in them, which this has now become. But I'll show you what to do anyway. And when you were looking at algebra, we were expanding brackets quite a lot. So if I'm going to, my next step really, my next simplest step is to expand this bracket. And you remember from algebra that we're going to use our crab clause or some other technique to make sure we expand this properly. So my left side of the equation at the moment is unchanged. 3 times minus x, remember your directed numbers, it's a positive times a negative, so we're going to get minus 3x. 3 times 15 is plus 45. Now it looks like one of these examples up here. So it's gone from being something quite tricky to something fairly simple. And that's what happens when you're solving stuff like this. Every step you cancel something, every step things become simpler. So in fact, it does look a lot like this first example here, and I'm going to do exactly the same steps. I'll add 3x to both sides. So I'm getting rid of a negative coefficient of x here, which would be confusing to work with later. So these cancel. I'm left now with 5x plus 5 equals 45. I'm going to subtract 5 from both sides. They cancel. I'm left with 5x equals 40. Divide both sides by 5, and I'm left with x equals, once I cancel those, 8. So you can see that by following the steps, being careful with where you're combining like terms, being careful with your directed numbers, you can now start to solve more complex examples.